Section 4. How do carbon dioxide concentrations in the atmosphere affect global climate? Digging deeper. Carbon dioxide and global climate. Correlations and cause and effect relationships. The relationship between carbon dioxide and global climate was mentioned in previous sections. You also explored this relationship in the Investigate. You did so using data sets and models. You saw that when there is more carbon dioxide in the atmosphere, global temperatures are higher. When there is less carbon dioxide in the atmosphere, they are lower. A scientist would say that there is a correlation between carbon dioxide and global temperature. You might think, oh, that's because carbon dioxide affects global temperature, and you might be right, but you might be wrong. It is important to keep in mind that a correlation does not, by itself, prove cause and effect. There are three possibilities. Number one, carbon dioxide affects temperature. Number two, temperature affects carbon dioxide. 3, both are affected by other factors and are independent of one another. Any one of these is consistent with the observations. It is the scientist's job to try to figure out which is the right answer. There are good reasons to think that the first possibility is the right one. That is because carbon dioxide is a greenhouse gas. Your model should have demonstrated that air temperature was greater in air that contains more carbon dioxide. What are greenhouse gases? The reason that Earth is warm enough to support life is that the atmosphere contains gases that let sunlight pass through. Some of these gases absorb some of the energy that is radiated back to space from Earth's surface. These gases are called greenhouse gases. The effect of these gases is in some ways like that of a greenhouse. A greenhouse is made of glass. Solar radiation passes through the glass. It warms the air and plants inside. However, the heat is trapped inside. Without greenhouse gases, Earth would be a frozen wasteland. Global temperatures would be much lower. Water vapor is the most important contributor to the greenhouse effect. Other greenhouse gases include carbon dioxide, methane, and nitrogen oxides. How do greenhouse gases help keep the Earth warm? Most solar radiation passes through the atmosphere without being absorbed. Some is reflected back to space by clouds first. It is absorbed by Earth's surface. There is a law in physics that states that all objects radiate electromagnetic radiation. The wavelength of the radiation depends on the object's surface temperature. The higher the temperature, the shorter the wavelength. The surface of the sun is extremely hot. It radiates much of its energy as visible light and other shorter wavelength radiation. The surface of Earth is much cooler. It also radiates energy. However, the energy has much longer wavelengths. Heat is in the infrared range, infra meaning below, and the color red is associated with the longest wavelength in the color spectrum. Greenhouse gases are those that absorb some of the outgoing infrared radiation. None of them absorb all of it. However, combined they absorb much of it. They then re-radiate some of the absorbed energy back to Earth. That is what keeps Earth warmer than if there were no greenhouse gases. The carbon cycle. Carbon dioxide gets into the atmosphere in two main ways. One way is during volcanic eruptions. Carbon dioxide is dissolved in magma below the surface. When the magma rises from inside the Earth and toward the surface, the carbon dioxide is released. The other way is by oxidation of organic matter. Oxidation of organic matter happens naturally in the biosphere. It occurs when plant and animal tissue decays. The organic matter is converted back to carbon dioxide and water. It also happens when animals breathe. When you breathe, you take in oxygen. Your body uses oxygen to oxidize organic matter, your food. Then you breathe out carbon dioxide. Carbon dioxide is also released when plants respire. Organic matter is also oxidized when it is burned. This type of oxidation occurs rapidly. Carbon dioxide is released into the atmosphere when wood is burned. It is also released by burning fossil fuels such as gasoline, natural gas, or coal. Plants consume carbon dioxide during photosynthesis. Carbon dioxide is also consumed during the weathering of some rocks. Both land plants and algae in the ocean use carbon dioxide to make organic matter. This acts as a storehouse for carbon dioxide. Carbon dioxide is constantly on the move from place to place. It is constantly being transformed from one form to another. The only way that it is removed from the active pool of carbon dioxide at or near Earth's surface is to be buried deeply with sediments. Even then, it is likely to re-enter the Earth's surface system later in geologic time. This may be a result of the uplift of continents and weathering of certain carbon-rich rocks. This transfer of carbon from one reservoir to another is illustrated in the carbon cycle. The carbon cycle is one of Earth's biogeochemical cycles. Carbon dioxide and climate. It appears that global temperatures are warmer when there is more carbon dioxide in the environment. Scientists have determined this from geologic data. This data is like the kind you worked with in the Investigate. To what extent is this because carbon dioxide in the atmosphere acts as a greenhouse gas? Think about this question on two different time scales. On a scale of hundreds of thousands of years, carbon dioxide and global temperature track each other very closely. This correlation occurs through several glacial, interglacial cycles. It is not easy to develop a model in which carbon dioxide is the cause and global temperature is the effect. It is much more likely that variations are due to Milankovitch cycles. They may explain the variation in both global temperature and carbon dioxide. On a scale of centuries, however, the picture is different. It seems very likely that the increase in carbon dioxide has been the cause of at least part of the recent climate change. Humans contribute to the total amount of greenhouse gases in the atmosphere. For a long time, humans have been adding a lot of carbon dioxide to the atmosphere. They have done this by burning of fossil fuels. This has especially increased in the past couple of centuries. Before the Industrial Revolution, carbon dioxide concentrations were lower. They were approximately 300 parts per million. During one time in geological history, concentrations of carbon dioxide were as high as 1,500 parts per million. This was during the Mississippian period. As of 2016, carbon dioxide concentrations were almost 400 parts per million. This represents a 10 parts per million increase since 2010. Scientists are concerned that the temperature of Earth may be increasing due to this increase of carbon dioxide in the atmosphere. Many nations have a commitment to reduce the total amount of greenhouse gases produced. It is their effort to reduce the risk of rapid global temperature increase. The trouble is that the size of the effect is still uncertain. Some people take the position that the increase in carbon dioxide should be reversed. They believe this is necessary even though the size of the contribution to climate change is not certain. It is their belief that the consequences would be very difficult to handle. Other people take a different position. They consider it to be unwise to disrupt the world's present economy. They consider the future danger to be questionable. The big problem is that no one is certain that rapid climate change will take place. If it does, it may be too late to do anything about it. Transfer of carbon dioxide from the atmosphere. Not all of the carbon dioxide released by burning fossil fuels stays in the atmosphere. Carbon dioxide is also dissolved in ocean water. As carbon is put into the atmosphere, some of it is absorbed by the oceans. That lessens the impact of the burning of fossil fuels on climate. Some people have even suggested that enormous quantities of carbon dioxide should be pumped into the oceans. That would tend, however, to just postpone the problem until later generations. Carbon dioxide is also stored by reforestation. Reforestation is the growth of forests on previously cleared land. There is a lot more forested land in the eastern United States now than at the time of the Civil War. The Civil War took place almost 150 years ago. The carbon dioxide absorbed by these newly planted trees is helping to remove some of the carbon dioxide emitted by human activities, such as the burning of fossil fuels. East of the Mississippi, expansion of suburbs and shopping malls continues. However, extensive reforestation is taking place.